Hey guys, today we'll be looking at derivatives of trig functions. So right here in this chart are all your trig functions, and it's good to know all these just so you don't have to go back and look at a chart. So for our first example, the derivative of f of x. So we're taking the derivative of 4 cosine x minus 7 sine x plus 2. So our constant stays out in front when we take the derivative, and the derivative of cosine of x is negative sine x. So I put that negative out in front. Minus 7, and now we take the derivative of sine of x, which is cosine of x. And we take the derivative of plus 2, which is a constant, will be 0. Now, on to our next example. So dy d theta, the derivative. Looks like we're going to have to use the product rule on this one. So this is our first term, and this is our second term. So we take the derivative of our first term. So derivative of secant of theta would be secant theta tangent theta times tangent theta, which is our second term, plus, now we take the derivative of our second term and multiply it by our first term. So the derivative of tangent of theta is secant squared theta times secant theta. Now we can multiply these through, and we'll get secant theta tangent squared theta plus secant cubed theta. Now, for simplifying, we can turn them into sines and cosines. So secant theta is equal to 1 over cosine theta times, and our tangent theta is sine over cosine, so it'll be sine squared theta over cosine squared theta, and plus, and our secant of theta again is 1 over cosine theta, so this will be 1 over cosine cubed theta. And you can see that we're going to get like terms on the bottom, so sine squared theta over cosine cubed theta when we multiply those together, plus 1 over cosine cubed theta. And this will all equal sine squared theta plus 1 all over cosine cubed theta. So that's for that example. Our last example, y equals x secant squared of 2x. So let's write this second term, our secant squared of 2x, in a different way because we're going to have to use chain rule. So secant of 2x all squared. So this is the same as this term right here. It's just easier when we're going to use the chain rule on it. In this problem, we're also going to have to use the product rule. So dy dx. So this is our first term and this is our second term. Take the derivative of our first term. So the derivative of x is 1, and we'll have our second term. So secant squared of 2x plus, now we have our first term times the derivative of our second term. So now we have to take the derivative of this right here. So I'll do it right here. So the derivative of this, we have to do chain rule. So you take that 2 out front, and you'll have your secant of 2x. And now you have to take the times your derivative of secant of 2x, which would be secant 2x tangent 2x. And now we have to take the derivative of the variance side, which is just that 2 times 2. So it's this x times all that up there, and I'll simplify all that. We'll have 4 secant squared 2x times tangent of 2x. And now in our next step, we'll be able to simplify even more. So secant squared 2x plus 4x secant squared of 2x times tangent of 2x. And again, we'll be able to change these into sines and cosines right now. So secant is 1 over cosine. So this would be 1 over cosine squared of 2x plus 4x, and secant squared again is, so this will all be over cosine squared of 2x from our secant, and tangent will turn into sine over cosine, so we'll have a sine on the top, sine of 2x, times a cosine of 2x on the bottom. And now I'll go into the next page on this. So this will all equal 1 over cosine squared of 2x plus 4x sine 2x all over cosine cubed of 2x. Now we can get like denominators. So we'll have to multiply by cosine of 2x over cosine. Oh, let me erase that real quick. We'll be multiplying by cosine 2x over cosine of 2x. So we're multiplying through by 1. So we can get like denominators. And this will equal cosine 2x over cosine cubed of 2x plus 4x sine of 2x. And it won't show up in this term because we'll just cancel them out. We'll have cosine of 2x over cosine of 2x, and we'll still have our cosine cubed on the bottom. So cosine cubed of 2x, and now we can combine them. So cosine 2x plus 4x sine of 2x, and this is all over cosine cubed of 2x. And those are your trig examples.